can now create robotic programs to pick and place objects. This enhancement uses existing generic motion capabilities to change tools and palletize parts, and can be used with machining programs to allow you to service the machine tool and perform functions such as polishing, linishing, and deburring. This example will illustrate how you can program the robotic arm to change tools and pick and place parts to perform a deburring operation. We'll begin by defining the pick and place junctions. First, we'll define 3 junctions for picking the parts. Then we'll define 3 junctions for placing the parts. Lastly, we'll define 1 junction for positioning the parts in the fixture. Next, we'll define the machine components. Machine components associate the picked junctions with the corresponding parts. The machine tool navigator should look like this. Now we can create the robotic operations. First, we'll create an operation that picks up the gripping tool. Then we'll create an operation that picks up part A and places it in the machining mount. The robot operation type is new. This operation type uses generic motion to define the robotic arm movements in a sequence of sub-operations. Note that a fake tool in this case, must be used so that sub-operations can specify reference junctions. If none is specified as the tool, then pocket junction is the only available reference junction. The first sub-operation defines the initial robotic arm position. The Robot Pose Target Move type allows you to jog the robot using the sliders or to select a named pose inherited from the parent program. The second sub-operation positions the spindle junction near the tool to be picked up. The Robot Cartesian Target Move type allows you to dynamically jog the robot arm, pick geometry, and enter specific positioning values. The third sub-operation engages the spindle junction to the gripping tool. Next, we'll create an operation that picks up part A and places it in the machining fixture. The first sub-operation lifts the gripping tool. The second sub-operation positions the tool near the mount junction for part A. The third sub-operation moves the tool to the part mount junction. The fourth sub-operation grips the part. The Robot Mount Move type allows you to select among all components classified in the Machine Tool Navigator and specify mount or unmount for each. After mounting, the component will move with the robot flange until unmounted. The next few sub-operations lift, rotate, and move the part into the machining fixture. The gripper releases and retracts from the part. The tool then returns to its home position. This completes the operation that picks up part A and places it in the machining fixture. The machining operation can now be moved after the part mounting operation in the program order view. Next, we'll create an operation that lifts part A off the machining fixture and sets it to one side. The first three sub-operations pick up the gripping tool and align it to the part mount junction. The next several sub-operations engage and grip the part, lift it from the fixture, move it to the place point, and release it. The tool then returns to its home position. You can now create the program for Part B by copying and editing the Part A program. In the Part B program, double-click to edit the copied operation. Edit the Move to Part sub-operation to position the tool above the mount junction for Part B. Edit the Engage to Part sub-operation to move the tool to the part mount junction. Edit the Mount Part sub-operation to mount Part B. Edit the Unmount Part sub-operation to unmount Part B. Edit the remaining sub-operations for Part B and Part C in a similar manner. Generate the tool paths and simulate the machine.
Siemens, ingenuity for life.